This video is about complete ionic and net ionic equations. Here I'm giving you the equation using words. So first thing you have to do is figure out what the words are standing for. So here I have lithium sulfide. Lithium has a charge of +1. Sulfur has a charge of -2. So lithium sulfide is going to be Li2. S, and they're telling you in the problem that it's aqueous, so I put AQ, plus copper 2 nitrate. So the copper has a charge of +2. Nitrate is a polyatomic ion, which has a charge of -1. So copper 2 nitrate is going to have the equation CuNO3 2, and that is also aqueous, because anything with nitrate is aqueous based on our solubility chart. Goes to produce what? So this is going to be a double replacement reaction. Is something burning, Sean? A double replacement reaction. So I'm going to put the cation of one with the anion of another, and then the cation of the first with the anion of the second. So it's going to be lithium nitrate. That's really bad. So lithium is +1, nitrate's -1, so I just put them together. And that's going to be aqueous, because anything with nitrate is aqueous. Sorry. Plus copper 2 with sulfur, and copper is +2, sulfur is -2, so it's just going to be CuS, and that is going to be insoluble, so I put solid. Now I need to balance this equation, so I have 2 nitrate over here and only 1 here, so I'm going to put 2 in front of the lithium nitrate, and that also, so now I have 2 lithium, 1 sulfur, 1 sulfur, 1 copper, 2 nitrate, and 2 nitrate. So this is my balanced chemical equation, and this, because it shows it as a molecule, is called my molecular equation. This, however, is not actually reflective of what's happening inside the solution, because it's depicting these aqueous ionic compounds as being associated with each other, and we know that that's not what they would actually look like inside our solution. So to view the actual, to view what it actually looks like inside the solution, we have what's called the complete ionic equation. And the purpose of a complete ionic equation is to show any soluble ionic compound that will dissociate as dissociated. So for my complete ionic compound, anything that's aqueous and ionic, it's going to split into its constituent ions. So lithium sulfide becomes 2 lithium ions, and as we said before, each lithium ion has a charge of +1, and that's going to be soluble, so I put my aqueous, plus 1 sulfur, a charge of -2, and that will also be AQ. So that's my first compound, plus 1 copper with a charge of +2, +2, and again, being that it's soluble, I put AQ, plus 2 nitrate, and that's also going to be aqueous. And now I'm going to put it on the next row because I don't have room here. So the products are going to be similarly, I'm actually just going to copy it, and it's going to be the lithium stays the same, so it's 2 lithium. The sulfur is not, so I'm going to erase that for now. This copper is not, but the nitrate is, so it's going to be 2 lithium plus 2 nitrate. Oops. Goes to, sorry, this thing's buggy. Goes to, I'm sorry. I don't know why the text box is so tiny, plus CuS solid. So this is my complete ionic equation, and it shows me everything that's actually happening inside the reaction. So anything that did split or could split did, and then my solid stays together. So this is fine because it actually shows us what's really happening, but it's a little bit messy and difficult to see the actual chemistry that's happening. So in order to zoom in on the chemistry, I'm going to eliminate everything that stays the same. And those things that stay the same are called spectator ions. So when I say stays the same, I mean it is still in the same state, so aqueous, liquid, solid on both sides of the equation. So lithium is 2Li plus 1 on the reactants, and it's 2Li plus 1 on the products. So that's a spectator ion. I'm going to cross it out. Sulfur changes because it goes from being aqueous to being a solid, so that isn't a spectator ion. Copper changes. It goes from being aqueous to being part of this solid compound, so that's not a spectator ion. Nitrate goes from being 2 nitrate. This should be 2 nitrate minus 1. Sorry about that. 2 nitrate minus 1 over here and 2 nitrate minus 1 over here. Again, it doesn't change, so it is a spectator ion. So what I'm left with is sulfur reacts with copper to form copper sulfate, and that is going to be what's called my net ionic equation. Okay, so in my net ionic equation, I'm just going to show the things that did change. So copper plus 2, and again, that's aqueous, reacts with sulfur minus 2, that's also aqueous, to form copper sulfide, well, copper 2 sulfide. And that's it.